All right, I am back. This is part three. So we need to go through and we need to remember our types of energy. Energy, we've got kinetic, that equals movement, and we've got potential. Potential equals stored energy. One thing that we need to recall is up here at point A, we have got stored energy. If it is stored, that means that it's not going to be moving. So right here at point A, if we take a car or a sled, let's think sled. This is going to have potential. Down here at point C, it's going to have kinetic. At point B, we've got some potential and some kinetic. Why does it have some potential? Because it has more to fall. Why does it have some kinetic? Well, we need to write some. Why does it have some kinetic? Because it is moving. If we keep going, eventually the sled or the car or the roller coaster eventually stops when it gets over here. The reason why the object stops over here is because my kinetic eventually turns into heat. And we do that with friction. So we've got potential at the top, we've got kinetic down here, and it still has kinetic. But if I go down a hill, even on a sled, it stops eventually. And when it stops, that's because it's converted kinetic into heat. So this is energy conversion. This is a really big concept. One other thing that I'd like you to understand, potential energy. This right here talks about gravitational potential energy, where something can fall down. As the height goes up, the PE goes up. That's going to be huge. So if I drop the sled from a taller point, it's eventually going to have more energy. Well, that energy gets moved or transferred into kinetic energy. And so if I start up even taller, I'm going to end up going even faster. And that's a really big concept for roller coasters. Think if I was going to go do a belly flop. If I do a belly flop into a pool, I'm going to have a bigger wave. Well, that transitions us down here. This right here, the wave height, is called amplitude. Amplitude equals a wave height. It's the same concept in just a different way of thinking with energy. If I am up taller, up higher on the hill, I'm going to end up with more energy. Well, if I am a taller wave, then I'm going to have more energy. So as energy goes up, amplitude amplitude goes up. Learn how to spell, Mr. Wadsworth. So amplitude goes up. So that's wave height. Um, we've talked about wave height. Now we need to get into what's called frequency. I'm wondering if this is going to show up over here. No, it doesn't. So right here, we need to go through and say that these waves are closer together. These waves are further apart. We would say that this has a frequency of 3. This has a frequency of 2. And this distance between this part and this part should be equal to this distance between this part and this part. This distance in between, or letter J up here, is going to be referred to as wavelength. Wavelength is the distance from crest to crest or trough to trough. This little point down here, H, is called a trough. That's what a piggy eats out of. It's what I teach my baby, little piggy. Not saying that that's what we teach kids as farm animals. Right here is F. F would be called the crest. Crest is right there at F. J is going to be the wavelength. So J is the, oh, let's move you over here. J is the wavelength. Crest is right here. H is the trough. And G is going to be the wave height, which is, once again, the amplitude. I'm going to just jump down to the bottom. This is the EM spectrum. I want you to understand that as the frequency goes up, or the number of peaks, as the number of peaks goes up, the energy goes up. So we have higher energy over here with lots of peaks really close together. If I'm over here with these radio waves, these are going to be lower energy. They're spread out. We could also say that longer wavelength equals lower energy. So we've got the whole concept of frequency versus wavelength right here. So if my spacing between the waves is up, it's lower energy. If this spacing is really close together, we're going to say it has higher frequency. So let's define frequency versus wavelength. Frequency is the number of peaks in a given time. Now we're going to go through and say this I realize that this is really close together. We would say that this has a high frequency, because if I was to continue this red line out in the same space that this takes up, I've got six peaks. So that's going to be high frequency. Down here, I've only got 3 peaks. So this would be a lower frequency. Lower frequency. If I've got a lower frequency, the distance between these peaks is going to be a lot bigger. So the distance from the peaks goes up when the frequency goes down. This peak to peak is a lot smaller than this peak to this peak. So we've been throwing a lot at you. Remember, this is parts of a wave. We've got amplitude as wave height. We've got frequency, which is the number of peaks. This would be a frequency of 6. This one would be a frequency of 3. Last but not least, if we have high frequency over here on this EM spectrum, we're going to have high energy, high amounts of energy. That's a lot of info. I'm going to stop there and we will come back with another video. I appreciate it.